Okay guys, here we go. We are going to be talking about secants first. This is a new definition, but guys, it's not very different from what we've already dealt with. It's going to be basically connected to a chord like a line is to a line segment. So let's show you what we mean. Getting started on this first thing. Secant. A secant is going to be a line that's in the same place in the same plane as the circle. It's going to intersect it. It's going to go through 2 points exactly. And it's going to contain a chord. Just like a line segment is inside of a line, a chord is inside of a secant. Here is a secant. This thing right here is a secant. Okay? It contains a chord that goes from here to here. That's the chord. The secant just extends all the way through. That's the only difference. All of these are going to be secants that contain specific chords. In this last case, it is going to contain the diameter. That's that special chord that we deal with. That's going to be that special one that you deal with. So when we take a look at this, you've got a total of, I think there's like 2 in the first one, 3 in the second one, 2 in the second one, and the third one, excuse me. So every single one of these is going to be secants containing a chord. For example, this is the chord contained by this secant. This right here would be the chord that's contained inside that. Basic idea, it's a line that draws to a circle, guys. Don't make it harder than it is. Alright? Now, when you have two secants that intersect each other, notice this is not central angles. The point is not of intersection is not at the center of the circle. This is an intersection anywhere else. If the intersection is inside the circle, we're going to break the rule down into something really easy, guys. Otherwise, it's going to be, these words, you're not going to want to remember this every time. You have to average the two arcs and intercepts. So we've got this 80 that intercepts on this side. We got the 60 that intercepts on this side. To find it, you're going to average, which means you're going to add and divide by 2. So whenever it has an intersection point where it intersects inside the circle, you are going to add and divide by 2. Right? That's one of our 3 rules, guys, right there. If it intersects inside, you are going to add and you are going to divide by 2. Add and divide by 2. So that's straightforward. Concerns, questions, anything about it? Okay, here we go. The next type. Whenever you have 2 of them that intersect on the circle, in this case you have a secant and a tangent. The secant and tangent have an intersection point that is on the circle. We've actually already done these. These are the old ones. Anytime the intersection point is on the circle, all you're going to do is take whatever the arc is and divide by 2. That was actually one of the word problems on the last quiz. What do you do with that? What's the relationship between the inscribed angle and the arc that it intercepts? The angle is going to be half of the arc. The arc is going to be double the angle. I took it either way that you wrote the answer. So in this case, if this is 120, this angle would be divide by 2, and that angle would be 60. Whenever the intersection point is on the circle, all you do is take that arc and divide by 2. Now, the other new one is going to be when you deal with the intersection point outside the circle. Guys, you have to be able to decide. They're going to be all mixed up on the test, and you've got to know. This is the thing you've got to know. Where do they intersect? These 3 all intersect outside of the circle. And when they intersect outside of the circle, there is a different rule. When it's outside the circle, you are going to subtract and you are going to divide by 2. Subtract and divide by 2. It doesn't matter if it's 2 secants like the first picture, a secant and a tangent like the second picture, or 2 tangents. The same rule applies to all 3 of these. The rule is, if the intersection point is outside the circle, you are going to subtract and divide by 2. For example, this one would be x equals 70 minus 40 divided by 2. Now guys, whenever you're doing this one and you're subtracting, you're always going to do the outside arc minus the inside arc, just so we're clear on that. Basically, it's the bigger one minus the smaller one because we don't want negative numbers when we're dealing with measurements. So anytime you have two arcs that you're subtracting, it always has to be the bigger one minus the smaller one. So grab your calculators. Excuse me for a second. This one's right. Yes. Not a problem. Okay, Michael, Mr. Werfel wants to see you. He said you are returning. You do not need to take your stuff. Do you know where that is over in the Nettles building? It's upstairs, backside.
Okay.
Back there. Yeah. He said it's no big deal. He'll send you back very shortly. Okay. Okay. Okay, guys. Here we go. Huh?
In the Nettles?
Nettles upstairs, back wall. Yeah.
What? Okay.
Thank you. Thank you very much. I appreciate that. Okay. Hey, Sue. Welcome. Okay, here we go. Guys, if you type this on the calculator, if you type 70 minus 40 divided by 2, you're going to get the wrong answer. Got to hit equals in between. If you don't hit equals in between, it's going to give you the wrong answer. If you do it correctly and do 70 minus 40 equals, and then hit divide by 2, you're going to get the correct answer, and the correct answer would be 15. If you do it the other way, it's going to give you 50, and it's going to give you the wrong answer. Be careful. Okay, you got to hit equals in between. Got to use that equal sign on the calculator. Here we go. Let's do it again. X equals, what number do you put first? The 190 minus the 50 divided by 2. Type it. See if you can get to that correct answer. Again, you got to hit equals. If you don't hit equals, it's going to give you the wrong thing. 70. There we go. And this next one's a little bit different. This is going to be more like the problems on the homework. You're going to see more and more of this. Guys, it requires you to use old stuff and mix it up with the new. We've had some old stuff. We had a quiz already. We should know how to do this. What does this arc measure out to out here? 260. That's that arc, the blue one right there. However, in order to do this problem, we also need this one that is on the... Sorry, I'm trying to figure out where this came from and why it's here. There we go. So we need this one on the inside in order to do this problem because we don't have another one to subtract from it. In order to find that, though, we use the idea that every circle adds up to 360. 360 minus that 260 is going to leave me how much for that inside arc? 100, right? 100. Then you can do the new math, which is still the same thing, which is the outside arc 260 minus that inside arc 100, all divided by 2. Outside minus inside divided by 2. Big one minus the small one divided by 2. What does that give you when you work it out? 80? Yes. Okay, so make sure I write down the right thing. Perfect, 80. Alright. Anybody see anything on those 3 rules that you need to ask about? Let's review them while you look. Guys, if the intersection point is inside the circle, you are going to add and divide by 2. If the intersection point is on the circle, you are going to just divide by 2. If the intersection point is outside the circle, you are going to subtract and divide by 2. Anything you see so far you need to ask about? Yes?
How do I type it on the calculator?
On the calculator, it would be 260 minus 100 equals, and then divide by 2 equals. If you do not hit that equals in between, it's going to give you the wrong answer. Because it's only going to divide the last number, not the whole thing, by 2. That's a very good question. Anybody else? It matters, guys, because the calculator, it does arithmetic and order of operations correctly. And if you don't hit the equals, it's not going to do it correctly. Okay. Here we go. The next ones. Okay, guys, you got to tell me which rule we're using because on the homework you've got to decide. All 4 of these use the same rule. Here is your intersection point for all 4 of these. I would mark them. Where is the intersection point on all 4 of these problems? Inside. And the rule, whenever it's inside, is to do what? Add and divide by 2. However, guys, that would be great if all you had to do was add and divide by 2 every time. That's not it. It's going to require algebra, it's going to require working backwards, it's going to require subtracting from 180 for the line. It requires lots of old stuff mixed with this one new rule. So here we go. This first one is direct. This x is right here. It's connected to the two arcs that are right in line with it. You can see they line up straight in a line. So all we would do to find x is we would add and divide by 2. This one's just direct. X equals 88 plus 76 divided by 2. All you're doing is like the direct. 88 plus 76 equals, divide by 2 equals. What's that give you when you do that math? I got two different answers, guys. Which one is it? 82. Again, you have to type 88 plus 76 equals, divide by 2 equals. Anybody have a concern? Okay, let's do it again. Guys, when you look at these two, this 62 and this 96 are not going to line up with the x. Do you see the x is not in line with them? The angle that's connected to them is going to be this angle. We'll call it y. We're going to be solving for y first. That's the one that's in line with those arcs right there. Okay, so we're going to do y equals, and we're going to add 62 plus 96, and we're going to divide by 2. Okay, do 62 plus 96 equals, divide by 2 equals, what's that give you on the calculator? 79? Okay. This angle right here would be 79. That's not the one we want. We want this one over here. We're going to use the idea, though, that every straight line adds up to 180. We're going to take 180 and we're going to subtract that 79, and that's going to leave me an angle for x that's equal to what? 101. Just want to make sure I get the right number. 101. Nicely done. Alright. On this next one, is the 60 in line with the x and the 25? Yes or no? Yes, they're all in line. Therefore, I'm going to take this one right here. That's actually my answer. I'm going to start with that. 60 equals, that's the angle. We already know the angle. And it's equal to x plus 25 divided by 2. Now, guys, this is algebra. It's just an equation. Just solve it like any two-step equation we've had all year long. To get rid of the denominator, you're going to multiply both sides by 2. When we multiply both sides by 2, 60 times 2 is going to put us at 120, right? Equals x plus 25. What do I do to solve it from there? Good. Minus the 25. And x is equal to 95? Okay. So make sure I get the right number. Awesome. Anybody see anything on that one they need to ask about? So this arc out here would be 95. So we're clear on what that is. Okay, this next one, guys, is the 95 in line with the x and the 101? No. So we need to find the angle that's in line with that before we do anything else. So we're going to use the idea that every straight line adds up to 180, and 180 minus that 95 is going to leave me what for that missing angle right there? 85. Now, these are now in line with each other. The x, the 85, and the 101. Okay? 85 is the angle we're going to be using. So the 85 is the answer. 85 is going to go first, and it's going to be equal to what? Yeah, the x plus the 101 divided by 2 equals that 85. Perfect. Nice. A lot of y'all. That's great. So, to go from here, we're going to multiply both sides by 2. 85 times 2 is going to be 160, 170. equals x plus 101. We're going to minus 101, minus 101, that's going to be 9. That's going to be 9, and then a 6 right here. 69 equals x. There we go. Alright, guys, look at this picture for a minute. First of all, let's just talk about this real quick. Does that arc on that side look smaller than the 101? No. Does it look like it should be a bigger number? Yes. Does it have to be drawn to scale? No. Be prepared for that. That really bothers me. I'm a very literal person. Being an algebra teacher too, I tend to think things are going to be what they look like they're going to be. That was always a challenge for me when I was in high school in geometry. If it does not, unless it says specifically it's drawn to scale, it does not have to look like the size, arc, or angle that it is. Just be prepared for that. Okay, guys, so look at this next set of 4 problems. On this next set of 4 problems, these are the easy 4. Just telling you up front, these are usually ones people do great on. Where is the intersection point for all 4 of these? On the circle. And anytime that your intersection point is on the circle, what is the rule when it's on the circle? Just take the arc and divide by 2. Whatever the arc is, divided by 2. That's the whole rule, guys. Just take the arc and cut it in half. This is the rule that's old. This was on the quiz. We're going to use it mixed up with this new stuff. So here we go. Here's an arc that's 250 degrees. If the arc is 250 and we need to get to the angle, we'll just cut that arc in half. So if it's 250, what's half of 250? 125 would be your answer there for example 5. For example 6, now this is a little different, guys. You've got the angle and you can only go to this arc from that angle. So if we take that 108, what do we do to the angle to go from the angle to the arc to go backwards? Multiply by 2. What is 108 times 2? 216? Okay, 216. Now, that is not the one we're looking for. We're looking for the x on the bottom. How can I find that using old information? Yeah, 360 minus that 216 is going to leave me what for x? 144. So x would be 144. Okay. This one uses the same idea. You've got the angle, you just don't have to go that extra step. If you have the angle, you're going to multiply by 2 to get to the arc. What is 116 times 2? 232. There we go. So that arc for x from here all the way around to here is going to be 232. Now, the next one doesn't require you to look at the angle in any way, shape, or form. This is old stuff, guys. Look just at the circle. What does every circle add up to? And I've already used up this 238, so just do 360 minus that 238. What's that going to give us? 122. Now, do I need to do anything to that 122 to get my final answer? Nope, that's it. It actually didn't require us to do anything with dividing. Guys, that was old stuff. The angle didn't do anything except cut that in half, that circle into different parts. And it's going to be just subtract that from 360. That's your final answer. Okay. Okay, guys, last rule, last 4 problems. What is it about these 4 problems that you need to know? Where is the intersection point for these 4 problems? Outside. Here. Here. The key is, because guys, they're going to be all mixed up on the homework. You got to be able to recognize that. That's the key. Where is the intersection point? Since the intersection point is outside the circle, what was the rule for outside? Subtract, perfect, and divide by 2. Subtract and divide by 2. Subtract and divide by 2. So, guys, some of them are going to be nice and direct. Not all of them, but some of them. This first one, it has the outside arc, it's 179. It has the inside arc, it's 71. To do this problem, you're just going to say x equals 179 minus that. Oh, thank you, sir. Thank you. I'll wait. 179 minus that 71 and divide by 2. 179 minus that 71 and divide by 2. Thank you, sir. Take her off. Thank you, sir. Appreciate that. Ooh, nice. Is it done, or do you still have another day of it?
It's done.
It's done? Nice. Nice. I know you're happy to have it finished. Okay, hopefully it went well for you. What's that give you math-wise when you finish that? 54? 54. There we go. Remember to hit the equals in between, guys. If you don't hit the equals, it's not going to be right. 179 minus 71 equals, then divide by 2 equals. Good. Okay, guys. This one is the same concept. The only difference is one of the arcs is missing. When one of the arcs is missing, it's going to be set up like this. The angle is 75, and it's equal to the outside arc, which is x, minus the inside arc, which is 50, all divided by 2. Guys, how do I get rid of that denominator of 2? Multiply by that 2 on both sides. That lets me cancel that out. That means on this side, I'm just going to bring down the x plus 50. On the other side, I'm going to multiply 75 times 2. 75 times 2 gives you what? 150. Oh, did I? Apologize. X minus 150. Thank you for saying something, not just leaving it. Now that we've got that 150 equals x minus 50, and it does matter, so thank you. We're going to add 50 to both sides. So that makes it 200. That math's not, I don't even need a calculator for that one. 150 plus 50 is going to leave me 200 equals x. So my arc out here is going to be 200. Okay, anybody see anything so far? We're going to do one more together. I'm going to try to get y'all to set up the last one. Okay, guys, we're missing the inside one this time. This is gonna require you to pay attention to a sign, guys. Watch this one carefully. When you set this up, it's gonna be 62. The angle is equal to the outside one, which is 141, minus the inside one, which is going to be x, all divided by 2. That minus x is gonna cause a problem for people. Please watch that carefully. You're going to have to get rid of that negative sign in front of that x eventually. Okay. So we're going to multiply both sides by 2. What is 62 times 2? 124 equals 141 minus x. How do I get the x by itself from this step? Subtract what? Yes, subtract the, I think it's 141, isn't it? Subtract the 141. That's going to give you a negative number. It's okay. You'll see what happens in a second. It's going to give you negative what? 17 equals the opposite of x, or negative x, or negative 1x, or whatever you want to call it. That's the opposite of x. Okay, guys, what number is really in front of here? Negative 1. So to get rid of that, you got to divide both sides by negative 1. And you'll see the negative takes care of itself, because a negative divided by negative is a positive, and 17 equals x. Just so we're very clear, can an arc be negative? No. Can an angle be negative? No. So if you get something that's negative, you got an issue. Now, can x be negative when you're solving for a piece of something? Yes, I have to say yes for that. I have to be clarified. But can the arc measure be negative? No. Can an angle measure be negative? No. Just so we're clear. Okay, set the last one up. Who set it up like that? Check and see. Pause for a second, guys. You don't need to do any of that work. Sometimes it's easier than y'all make it out to be. Guys, it's a circle. Every circle adds up to what? You already used up 140. The rest of it is the rest of the circle. So 360 minus 140 is 220. Don't need to do any of that other work. Can you get the same answer doing it the other way? Yes, watch. I'll do it for you just so you can see it. It'll be 80 equals x minus 140. Add 140. Add 140. You still get 220. Do you need to do it the long way? No. Okay, guys, that's your notes. From here, when you are done, put that. I wouldn't actually put this one away because the rules